Hey, Science 8, Mr. Drzezinski. This is the video that goes with the exercise for measuring. It's called the measurement activity. And the measurement activity is going to ask you to measure a small and a medium and a large block of wood. You'll be measuring the width and the height and the depth, calculating the areas on the three sides, and then calculating the volume. Eventually, we'll calculate the density. Some of the things that I have to do this exercise today include the triple beam balance. I needed that to measure the mass of this big piece. And I got the digital scale, which I use to measure the masses of the little pieces. I also have my calculator, which is going to be useful for calculating density. And then, of course, the metric scale to do the measurements. Okay, let's start with the first step. It asks you to use a centimeter scale to measure the width, the height, and the depth of the smallest block. I'm going to take the smallest block here and place my scale across it. It looks like it's at 4.8 centimeters. I'm going to change to the height. The height also looks like 4.8 centimeters. And then I'm going to dimension the depth. The depth looks like 2.5 centimeters. I'll show you a close-up of those values. After calculating the height, the width, and the depth, we can do a calculation to determine the area. The area of the front, we're going to multiply the width times the height, which you have there, and you can do with the calculator. The area of the top, you can multiply the width times the depth, again with the calculator. And the side, you can calculate the height times the depth to get the side. That'll give you the two-dimensional areas of the front, two-dimensional area of the top, two-dimensional area of the side. Use your calculator on your Chromebook or on your phone to do step 2. Step 3 asks you to find the volume of the smallest block. The volume is the three-dimensional space that it takes up. I can multiply the width times the height times the depth. Again, with your calculator, width times height times depth to do number 3 to get you the volume. Step number 4 asks you to measure the mass of the small block. I can put the mass of the small block either on the triple beam balance or the digital scale. In order to calculate with either one of these, you got to make sure that the scales start with a reading of 0. I'd also like to read these in grams, so you make sure each of these are set in grams. Okay. The reading for the small block happens to go to 32.8 grams. For step 4A, 32.8 grams. The last step there, it says to calculate the density. The density is the mass divided by volume. You can use the mass from 4A, divide it by the volume at 3A, mass divided by volume, and that'll give you the density. Please remember on all of these steps to put the units. The units for all of the distances here are centimeters. The units for the areas are centimeters squared. The units for the volume is centimeters cubed. The density was the mass was in grams, and the density was in grams per cubic centimeters. Okay, let's go on to the second block. I'm on step number 6 of the measurement activity. It asked me to take the middle size block, measure the width, the height, and the depth of the middle size block. I'm going to use my metric scale, put it across we're going to put it on this way, put it across this short axis. It looks like 3.6. The height, put it on this axis. That looks more like 4.04 centimeters. And then the depth, I'm going to put it on this axis, and that looks like 10 centimeters. 3.6, 4.0, 10 centimeters for 6A, 6B, and 6C. Again, we'll use our calculator to determine the areas. The area on the front face, we're going to multiply the width times the height. The area on the top face, we're going to multiply the width times the depth. The area on the side, we're going to multiply the height times the depth. Do your multiplications there to get the areas. Remember, the units are in centimeters squared, cm raised to the 2 second power. Again, we can use our calculator to calculate the volume, three-dimensional space of this middle cube by multiplying the width times the height times the depth. Width times height times depth. The units there would be cubic centimeters, cm to the third. Can put the middle size block on the digital scale to calculate the mass. Making sure that it starts with a reading of 0, I have 73.1 grams, 73.1 grams. And then step number 10 asks you to calculate the density of the middle size block. You're going to take mass divided by volume. Mass is 9A's answer. Volume is 8A's answer. Use your calculator to do mass divided by volume, and you'll get grams per cubic centimeters as the units. If you wanted to compare the density of these two pieces of wood, they should be very similar. This middle-sized block happens to be from a piece of treated lumber, and it's a little bit heavier, and the density is a little bit more. Both of these blocks, I believe, should float in water, which would make their densities less than 1. And the last part of this measurement activity asks you to do the same thing with the large size block. Step number 11 is going to ask us to determine the width of the block. I'm going to guess that's around 4.3. It's going to ask us to determine the height of the block. I'm going to guess that's around, I'm saying 7 centimeters, 7.0 centimeters. And then it's going to ask us to determine the depth of the block. And that looks like 27.8 centimeters. You notice when I use the centimeters scale, I'm not measuring from the very end of the scale, but I'm measuring from the 0 position. They put the 0 position on the scale a little bit in from the end in case the end of the scale gets damaged. You can still measure accurately from the 0 position. Okay, I'll show you those again for the width and the height and the depth of the big block. When it comes to calculating the area, you're going to use your calculator again. To calculate area of this front surface, you'll multiply the width times the height. Width times height for that area. The top area here, you're going to multiply the width times the depth. Width times depth. And then this side area, the big area, you multiply the height times the depth. All three of these areas are going to have the units of centimeters squared, cm squared, or cm to the power of 2. So that'll give you those areas on those faces. Step number 13, it wants you to calculate the volume. The volume, you're going to multiply the width times the height times the depth. Multiply all three of those dimensions to get the volume of the piece. And the units there are cubic centimeters, centimeters to the cube, or third. Okay. Step number 14 asks us to calculate the mass of this. I happen to put the large block on the digital scale, but the digital scale doesn't go to that capacity. This scale only reads to some 200 grams. This ended up being more than 200 grams. You take a look at the triple beam balance. Right now on the left-hand side, you'll see the needle is balanced. If I put the weight on the scale, and then I'll use this slider to determine the scale. If I put it at 300, it's not quite heavy enough. If I put it at 400, it's too heavy. So I'm going to put it back at 300 and slide the tens bar. The tens bar at 50 is not heavy enough. The tens bar at 60 is too heavy. So I'm going to put it back on the 50. This is so far 350 grams. And then the last one's value I'm going to use on this dial until I get the pointer lined up again. This piece of wood is going to end up weighing 352.5 grams. 352.5 grams is what I have today. The last thing that we do on the exercise is calculate the density. The density is going to be mass divided by volume. So you'll take this mass divided by the volume. You can do that with your calculator. Get grams per cubic centimeter as the units. Please add all of the units for your exercise. Okay, that's the measurement activity. You want to complete that, hit turn in on the Google Classroom, and I will give it a grade. Thank you.